Wait, why? It's so old. It's from when I was in college. Huh? Like it makes the clicky clack? Is that what you mean?
This keyboard, it was like sticky and like slow.
Oh, mine's not. I thought you said squishy. No, it's not sticky.
Like no, it's not the not like the honey you stick on it. Like you press it
And it like doesn't pop up.
right up.
Oh no, it's great. You should in a little bit do a little type on it and see. It's nice. Doesn't it feel great? Just
Resistance.
yeah, I mean it is old. I mean somewhat. All right.
Yeah.
Okay. Okay, so we are learning U substitution today. And U substitution at the beginning, it's a lot of steps. Okay, by the 5th or 6th example, hopefully we'll be moving. But if we're not all locked in at the beginning, we'll have to do all the examples really slow and it'll eat up a lot of class time. So let's try to really lock in right now. Then I know y'all have from this week. So we're doing this type of stuff Monday and Wednesday. On Friday, we're going to do a couple of like advanced integration things that are on the AP test. But if you never do it, it's up to you. Like we're going to just move on to the next thing next week. So you have one homework grade that's dropped. So if you never go back and do Friday's assignment, I'm not going to cry about it. Neither should you. Okay. But it will be difficult to get a 5 if you don't go back. Okay. On the AP test. Okay. But a 3-4 easy without that day. Okay. So U substitution is essentially trying to undo the chain rule. Okay, so if you don't remember what the chain rule is, let me sort of remind you. So take your paper, flip it over to the back side. Okay, we're going to just write on question 23, just to make sure you remember what the chain rule is. Okay, so we're not going to end up doing that. Okay, if I asked you in semester 1, let's say maybe October, to take the derivative of the sine of 4x squared plus 3x. Okay, chain rule says that you take the derivative of the outside layer. So for example, sine, what would the derivative of that go to? Cosine, and then you would keep the core the same. But then what would you do with the core? Okay, take its derivative, and then you would multiply it either at the front or the back, it doesn't matter. So if this is your U, what would your U prime be? So 2 times 4 would be 8x, and then plus 3x would go to a plus 3. Okay? Now, also keep in mind your 8x plus 3, you could times it, like I said, at the back, it doesn't really matter. Okay, let's do 2 more examples. Next one is going to be the derivative of, let's do 5x cubed plus ln x to the 7th power. And actually, let's put a 2 in front of that. So the first thing I want you to do is think about the outside layer is a 2 in the front with a 7th power up top. How do I take the derivative with this number? What do I do with it? Multiply it down times the front. So what's my 2 now if I times it by 7? Okay, and then remember, my core stays the same. But then what do I do to the power when I take a derivative? -1. So my 7 power will drop down to a 6 power. And then I would take whatever the core is, and I would multiply its derivative behind it. So what's the derivative of 5x cubed plus ln x? 15x squared, and then ln, the derivative goes to 1 over x. Okay? So this is my u, then this is my u prime. This was my u, then this was my u prime. Okay, and there's no fancy determination of whether you put it at the back or the front. It could go either one. Okay, last one. Let's say you're taking the derivative of e to the 4x minus 8x to the 4th. Okay, what is the derivative of e to a power? Remember, e stays the same. It'll be e to the exact same power. But then I have to multiply by the derivative of that power. What would the derivative of 4x minus 8x to the 4 be? So 4x, when I take the derivative, would just go to a 4. And then remember, I do 4 times 8 is a 32. Drop the power down. So it'd be a 32x3. Okay, where this is my u. And this is my u prime. Okay, we kind of remember this a little bit. Okay, so undoing an antiderivative on a chain rule is a little bit complicated, and here's why. If the derivative of this gives me this, then the antiderivative of this would go back to what I started with. However, notice that when I'm going the antiderivative route, this has to already be there for me to be able to do it. Okay, same thing here. If I want to do the antiderivative on this to the 6th power, the middle stuff of that, the derivative has to already be present because of chain rule. So go back to the front. We're going to work through some steps. And hopefully you'll know how to do antiderivatives with chain rule. All right, step number 1 is you are going to identify what your u should be. U should be x stuff that is inside, let's say, other operations or functions. Okay, so just like we were picking what our core was for chain rule, okay, you're going to pick what your core is for the antiderivative. So let's say, for example, on number 1, what do you take a guess? Think that the core probably is? 1 minus 4x. Very good. Okay, look at the one below that. What do you guess the core is? X cubed plus 2. Okay, and the reason why is that it has to be inside other stuff. So like on this one, I'm not picking the 5x squared because it's not inside anything. Okay, so the first thing you're going to do is you're going to pick your u. So I picked 1 minus 4x for the first one. Okay, step number 2. I choose my u step 1. Step number 2 is I'm going to take the derivative and I'm going to call it du dx. Now, think about what that stands for. Okay, du dx means the derivative of u with respect to x. Okay, that's what du dx stands for, is that I'm taking the derivative of u and x is my variable. So if my u is a 1 minus 4x, take the derivative of that for me, and we're going to call it du dx. What would the derivative of the 1 be by itself? 0, because remember, constants alone go to 0. What about the minus 4x? Just a minus 4. Very good. Okay, done with step 2. Step 3 is that you're going to solve to get dx by itself. Now you'll notice that dx is on the bottom of this fraction. So I'm going to multiply by dx on both sides. That will cross it out from the left. So far I have du equals negative 4 dx. Okay, then remember, I want dx alone. So if it's multiplied with a negative 4, what can I do with that? Divide it to the other side. So I'm going to divide by -4. So that now I have dx equals du over negative. Okay. Box the first thing in that and the last thing. Okay, we are going to use both of these pieces that you put in your box for step 4. Read what it says. We're going to take the original integral and we're going to substitute it into u's and du's. No more x's should be left after you substitute. So rewrite your integral. The 24 is going to stay the same. But where my 1 minus 4x is, I'm switching that into what? What is 1 minus 4x going to be replaced by? A u. So instead of it being 1 minus 4x cubed, now it's u cubed. Okay, then when I see my dx here at the back, I'm going to replace that using this bottom step. That dx is going to be replaced by a du divided by -4. Okay, so the two things that I have highlighted are being replaced. The 1 minus 4x is now a u. Notice the cubed is still there. And my dx is now a du over -4. Okay, then it says factor out any constants if needed. That's referring to the 24 and the divided by -4. We can just go ahead and do that division. So what is 24 divided by -4? -6. So I have -6 u cubed du. Okay, from here, look at the next step. So I did my substitution. I did my constant. Now I'm ready to take the antiderivative. Remember, for any antiderivative, you add 1 to the power, then divide. So if this is an u3, what's the antiderivative going to be? U to the 4. And then what do I do with the 4? Divide it on the constant in the front. So it's a -6 over 4 plus c. And then in your very last step, you're going to rewrite it back into terms of x. So this would be -3 over 2, just because I'm going to reduce the 6/4. And then instead of my u, I'm going to plug the 1 minus 4x back in. So if it's a u to the 4, now it's a 1 minus 4x to the 4 plus c. Okay? All right, let's do another one. The first couple, hopefully it'll take a little bit of time to solidify the steps, but then hopefully it won't be too bad. All right, next one. What did we say we're going to pick as our u? Okay, u is going to be x cubed plus 2. After you choose your u, you're going to take the derivative, which I'm going to call du dx. Remember, that stands for the derivative of u with respect to x. Okay, what's the derivative of that? 3x squared is correct. What happens to the 2? Goes to 0. Very good. Okay, next step. Follow along on your list. We identified the u. We identified our u. We took the derivative. What's next? Solve for dx. So I'm going to have to times my dx up. And then I'm going to have to divide my 3x squared down. So it's a 3x squared dx. And then divide the 3x squared down. So I have du over 3x squared equals dx. Box the first and the last. Okay, and we're going to use those two pieces to rewrite our integral with no x's left. So let's do it. My x cubed plus 2, what's that going to turn into? A u, and then what power did it have on it? A 4. Then I get to the 5x squared. I don't have a substitution for that, so I'm just going to leave it. Then I get to the dx and I have a substitution for that. What's going into the dx spot? A du over 3x squared. Now, remember what I said. Once you rewrite this, it should only be u's. And I see that I have some x's, but why is that not a problem? One of my x squareds is on top, the other one's on bottom. What are they going to do? Cancel out. So if you have x squareds at this, or any x at this step, they should cross out. Okay, so from here, I'm going to rewrite my integral. It's going to be a 5/3 u to the 4th. Okay, and remember, if you have two numbers, either go ahead and divide them, or if you can't evenly divide them, just leave it as fraction. Okay, we're ready to take the antiderivative. U is to the 4th power. Add 1, what's the new power? 5th. And then what do I do with the 5 after I increase the power by 1? Okay, technically I'm dividing it, which is the same as multiplying by the reciprocal. So if my u goes to the 5th, I have to divide by 5, which means I put a 1/5 right here. Don't forget your plus c. And then what's going to happen with those 5s in the front? Cancel them out. So really, it's going to be 1/3 u to the 5th, but then remember, I'm not going to leave it as a u. I'm going to switch it back to x's in my final answer. So it'll be 1/3 u to the 5th, and then put that x stuff back. So my u is an x cubed plus 2. That would go back into the fifth. Make sense? Okay, turn the page. Next one, I want you to try to pick what you think your u should be. Okay, so give it a sec. Or actually, let's do 4 first. We'll come back to 3. So look at number 4. Take a guess. What do you think my u should probably be? It is 5x plus 1. Now, if I ask you, what is that inside? Just think it's inside the fraction. That counts as a function. It's inside the division. So write down u equals 5x plus 1. What's the next step? Find du dx, which would be the derivative of 5x plus 1. What is that? 5. And then remember, I need this dx alone. So I'm going to times the dx up and then divide the 5 down. So du is 5 dx, then divide by 5 on both sides. So I have du over 5 is going to replace where my dx is. Box the top sub, box the bottom. Okay, let me give you a second. Rewrite your integral. You should have no more x's when you sub those. So I had a 10 over 5x plus 1. What is it going to say now? 10 over u. Right? Because my 5x plus 1 is turning into a u. And then where my dx is, I'm going to replace it with a du over 5. Can I divide the numbers that I got? 10 divided by 5, will that go evenly? 2. So I have 2 over u du. Now, this is a special. Okay, and I'm going to rewrite it as 2 times 1 over u du. Okay, remember, these are the same. So if you have 2 over just a u by itself, what's the antiderivative of this going to be? 1 over u. What does it go back to? ln u. Yeah? So this is going to go to 2 ln absolute value u plus c. And then I would just switch my u back. So it'd be 5x plus 1 on the inside. like that. Okay, can you try number 5 to set up just this first part right here? So pick your U and then go through those first few steps on number 5, then we'll go back to 3. U should be 2x minus 1. If you didn't pick that, it'll mess kind of everything else up. And then once you have that, go ahead and try your rewrite.
Body shaming my integral. Why you body shaming my integral?
Wait, what's wrong with your integral?
Just body shaming my integral.
It's thick. Not
Body shaming.
thick and juicy.
Yours is like anorexic.
Bro, mine is
Nothing,
like,
dude.
what? Bro,
Yours
mine
is
is,
anorexic.
alright, that's what happened.
Kind of cut way too long. I haven't cut way too long.
All right, you should have this.
Yes.
Okay. So your U is a 2x minus 1. That means your derivative is just a 2, which means you're going to be replacing a du over 2. So my integral, I have a 7 on top over a u, and then what power was on the 2x minus 1? Yes. What power was on it? So that needs to stay. So make sure that if your u had extra stuff with it, like it was in a square root or it has a power, that should still be there. Okay, then my dx is subbing out for a du over 2. Okay, take those numbers, pull them to the outside. Okay, if 7 could divide by 2, I would do it, but it won't. So I'm going to leave this as 7 over 2. Now, if my u is on the bottom, what rewrite could I do so that I can power rule that? Oh, this is supposed to be a 2, not a u, sorry. Okay, so 7 over 2, and then my u is going to be to the minus 3. Okay, remember that if it's a 1 over u, that goes back to ln. But if it's a power, you need to use a negative to pull that up. Okay, gentlemen. You're just being a little silly, guys. Okay, add 1 to your power. What is it now? U will now be to the negative 2 because I have to add 1. And then if I'm dividing by a negative 2, my 7 halves is going to have a negative 1/2 with it. Okay, then from there, remember fractions, you times straight across the top, straight across the bottom. So what will that fraction in the front be? 7 over 4, right? So you got to times them. And then my u is going to go back to a 2x minus 1 plus. Now, as far as your delta math goes, this is fine. On the AP test, where would they put this if it has a negative squared on it? Back into the bottom. So I'm going to put here, this would be the same as 7 over 4 2x minus 1 squared plus. Okay, for delta math, first box is totally fine. But for AP, now they would take it this way, but if it's multiple choice, you'd need to know that these are the same. Okay? All right, go back to number 3. Pick your U. Okay, number 3, if I pick the 4x minus 6, what is it inside of? What is 4x minus 6 inside of? Nothing. It has to be inside a bigger function, right? So what should I pick on number 3? Okay, so do your beginning part. Okay, these first few steps. So x squared plus 3x, we want something that's like the most on the inside. Okay, then we're going to take the derivative. What is the derivative of x squared plus 3x? 2x plus 3. Then remember, my dx is going to multiply up. My 2x plus 3 is going to divide down. So you should have that your du over 2x plus 3 is going to replace the dx. Okay, come over here and rewrite your integral. So I want square root x squared plus 3x. What's that going to turn into? Square root u. Very good. And remember, the u has to stay in the square root. Okay, then my 4x plus 6 is just chilling for now. And then when I get to my dx, it's going to turn into this. So a du over 2x plus 3. Okay, and then remember what I said. At this step, all your x's should be gone. And I see that that's not the case because these don't cross out. Is there a way that I could make this look like this? Take out a what? A 2. So I'm going to factor this to be 2 times 2x plus 3. And if I rewrite it like that, then now I see, oh, they can cross out, but I'm going to still have the 2 left over that I would have GCF'd out. So these are still gone, but I'm going to have to keep that 2 in the front. What rewrite will I use on the square root of u? 1/2. Okay, and then there are a couple of these on your homework that if it's a half, how do I add 1? What would I call like the plus 1? I would do 1/2 plus 2/2 gives me 3. And then if I get a 3/2 and I have to divide by that, do you remember you like flip it down to the front? So that now it'd be a 2/3. Okay, so you're going to still add 1, but you're adding it as 2/2. 1/2 plus 2/2 is 3/2, then flip it to the front. What is 2 times 2/3? Okay, 4/3, u to the 3/2, and then put your u back in as an x squared plus 3x. Okay. How do we feel like it's going? You get it? All right. Go ahead and try number 6 all the way through. You can do it.
What?
No, because like, I don't know if your phone does it, but like, you know, like sometimes like you bring it out, it's like your face, like, say like your phone is.
Okay, so we're thinking over you.
My phone, bro, my mom like put it on my phone. But if I cook, so just like, oh, bring your phone away. Like, hey, like, do anything, but it's like that.
What are these excuses?
Oh, okay. I still want the game, but like, whenever you get the extra like a big face.
Okay, then do you dx.
Well, I was like clicking it, I was like, where? It's like it's straight.
Okay, what are we picking as our u? Let's not take the thing. Let's just take what's inside the u. Just the 4x. Because remember, if you make your u too big, then you want like what's the most inside. So 4x squared, then take the derivative du dx. And then when you do your rewrites, you'll do integral e to the u. You have a rule, for that, right? You're just taking the top.
You get to start it, so it's
So that when you do your rewrites,
Bro, it's 8 days.
does that make sense?
Bro, you don't put the thing in there, bro. You let it eat, bro. Look at your size, everything right or so. I still ate it.
Well, you're doing the chain rule backwards already. Don't worry about that. Just follow your steps.
All right.
Did you get this?
Yeah, I got it.
So then now when you rewrote it, that's right, that's good.
Yeah.
So it'd be e to the u, your 16x is chilling. And then your dx goes to a du over 8x. Now remember, you're not allowed to have x's left. But why is that okay? What's gonna happen to the x? Because one's on top and one's on bottom. And then what number will you keep in the front?
2.
So it'll be the integral of 2e to the u. And then remember, we have a rule for e to the u. What's the antiderivative of e to the u? E is its own, right?
Yeah.
So e to the u will go to e to the u again plus. Okay, look up if you need help.
So.
Okay. So then in this step, you do cross those x's out, and then 16 divided by 8 gives you a what in the front? So it's 2 e to the u. And then you put the little integral down. And now what's the antiderivative of
It's like small.
So it'll go to the 2 would stay in the front, correct? Okay, so you should have gotten to here. Okay, remember e to the u is its own antiderivative. Don't forget the plus c. And then we just put our x stuff back in. So it'd be 2e to the 4x squared plus c. Questions on that? Okay, we're gonna run through a couple different question setups. But if you know how to do U sub, this is just different types of questions you'll see on your homework. So go down to the next one. If you actually, let's skip that one. Let's do one where the X's and the Y's are mixed up. Go for me to number 13. All right, so you just took a test over separable differential equations. That's where the y and the x stuff is all kind of jumbled together. What step would I take to separate dy dx equals e to the 2x over y? Okay, but hold on. If the y is already on the bottom, will it be a 1 over y here? It would be a times y. So I'm going to multiply by y on both sides. These guys will cross out. And then I'll multiply by dx on both sides. These guys will cross out. So you should have y dy equals e to the 2x dx. Okay, this is what we just took a test over. So you separate. And then do what next? Take the antiderivative on both sides. And now for this note, at least one side is going to require U substitution. Okay, if I'm integrating just a y by itself, does that need U sub? No, because there's nothing inside anything else. What is the antiderivative of y? Up the power, then divide. 1/2 y squared. Okay, but then on this side, this is the side that needs u sub. Okay, and the reason why is because it's not just an e to the x, it's an e to the 2x, where 2x is inside the e. So this side is going to need u sub. What should my u be? 2x. What's my du dx? What's the derivative of 2x? Just a 2. And then remember, I'm going to times the dx up and divide the 2 down. So my du over 2 is going to replace where my dx is. These are the two pieces you're switching, okay, that are circled in yellow. My 2x is going to go back to a u. My dx is going to go to a du over 2. So it'll be like this. E to the u, and then du over 2. How can I rewrite this with the divided by 2? It's really like a 1/2 e to the u. And then what is the integral of e to the u we just said? E to the u again. So let's come over here. We have 1/2 y squared. Yes?
Why would we know it's by 2?
Because it's a divide by 2. So just pretend like this is a 1 du, then that's a 1/2 that would need to be in the front.
Oh.
Yeah? Okay, then from there we said the integral of a 1/2 e to the u is a 1/2 e to the u again. But then I'm going to switch my u back for a 2x plus c. And then from here, this is what you should already know how to do. I want to get that y by itself. That means I need to eliminate this 1/2. How do I do that? Multiply by 2. So the 1/2 and the 2 are gone. I have y squared equals. 1/2 of 2 there makes that a regular e to the 2x plus c. And then what would my next step be? If it's a y squared, I would take the square root. So I have e to the 2x plus c. Is that correct for my general solution? No. What am I missing? Okay, very good. Remember, your general solution, if you take a square root, should have a plus or minus on it. Okay, then they didn't give you an ordered pair to find the c, so we can just leave it. All right, maybe we'll do 2 more of those, then we'll call it quits. Sure. Try number 14. You're going to separate first, integrate on both sides, and then think about which side needs u sub. Very nice one.
Oh, you.
Okay, very next one. Jordan, are you still writing it? Okay. All right. So let's separate it first. Two more questions. I have no idea, but I know it's on Friday. Because I know it's senior skip day. I wonder if any of you will be here.
Barrel. Or has to go to work here.
You really will?
Yeah, I don't know.
No, I will. What time is Friday? Oh, you have that stellar attendance.
You actually care that much? Yeah.
This for years, the whole day.
Take the risk, bro.
It's like a rule for like sports, like extra breaks. Do you be 6Y?
Huh?
Wait, no.
You gotta separate it before you can pick a U.
2X.
All right, let's power through. 2 more. Let's finish it. Okay, what do I do with the 6y if it's on the bottom? I'm going to multiply it. So it's a 6y dy and then a sine 2x dx. So remember, step one is the dx moves over here, the 6y moves over here. Which of those sides will require u sub? The y's or the x's? The x's, because it's not just sine x. What is it? Sine 2x. So let's do this antiderivative first because it's easy. 6y, you're going to up the power, then divide. What'll that go to? 3y squared. Equals. Okay, then on this side, we need u sub. So let's pick what our u is going to be. What is our u going to be? 2x. Then what's du dx? Derivative is just a 2, but I'm going to end up with a du over 2 to swap my dx. So it's going to be du is 2 dx. Du over 2 is dx. Okay, top and bottom are what you're using to substitute the 2x and the dx. My sine 2x is now a what? Sine u. And then my dx is a du over 2. Okay, before you do anything, rewrite that over 2. I'm going to pull it to the front as what number? A 1/2 sine u du. Okay, then from here, snow cone, snow cone. You're on positive sign. Which way do I go, up or down for an antiderivative? Antiderivatives are up. So if I'm already at the top, where do I end up when I go up? Negative 1/2 cosine u plus c. The du, you can think about it, turns into a c. Remember, these are like part of the same notation. Integral du means antiderivative with respect to u. So when you do the rule, the du goes away. Okay, then from here, we're going to turn that into a cosine 2x. And then I'm going to just carry the 3y squared down so that I can keep solving. What would my next step be to get rid of the times 3? Divide by 3. Okay, and I'm going to think about that as a third. What happens when you a third on a half? A 6. Remember, you times the tops times the bottoms. So 1 times 1 is 1. 3 times 2 is 6. And then cosine 2x plus c. Next step. Take the square root. So it'd be plus or minus negative 1 over 6 cosine 2x plus c. All right. Very last one that we're going to do together is number 19. Turn to it, please. Number 19. Okay, go ahead and do your separation. Or actually, we've already done a few. Let's do 20 instead. We've already done some e's. So never mind, I picked number 20. Okay, first thing, I noticed my y is on the bottom. How am I going to move it across to the other side? Multiply. So now I have a y dy. And then I have a 4 secant squared 2t. Let's just turn it into an x, just to keep our lives easy. So 2x dx. Okay, they use t's, but I'm just going to make it an x. Which side, integral on both sides, which side is going to need u sub? The y's or the x's? The x's. The y is good. What's the antiderivative of y by itself? 1/2 y squared. Okay, but then on my x side, I'm going to need u substitution. What will my u be off the right-hand side? 2x. Then du dx will be whatever the derivative is of that, which is what number? 2x derivative is just a 2. Then remember, my dx will multiply up, my 2 will divide down. So dx is going to equal du over 2. Then remember, these are my two swaps. So the 2x and the dx are going to be the pieces that I exchange here. Go ahead and rewrite this. It'll be 4 secant squared, and then what? U, and then my dx is a du over 2. And then remember, if you have a number, you want to divide it with what number is already here. So 4 divided by 2 is what? So I have 1/2 y squared equals 2 secant squared u du. And this is a rule. Does anyone remember the integral of secant squared? And wow, good memory. Okay, so the integral of secant squared goes back to tan, because the derivative of tan is secant squared, then the antiderivative of secant squared is tan. So it'd be 2 tan u plus c. And then remember, you would take your u and pop the 2x back into that spot. So it'd be 1/2 y squared 2 tan 2x. Okay, what would my last couple of steps be to finish solving that? Multiply by 2, then take the square root. So this would go to a 4 in front. Tan 2x. And then plus or minus square root. Now, you will notice, okay, that on this question, do you see how it asks you for the particular solution and then it gives you a point? Okay, we're not going to do those questions today. So for now, for your homework, this is good enough for everything till the level 2s. Don't do any level 2s today. Okay? All right, good job, guys. If you cannot do today's homework, you're going to really have a hard time on Wednesday. So I want everyone to pick at least 4 problems and do them successfully before they leave in 40 minutes. Okay, and then if you need to work on something else, that's fine. Yes, Linus.
I have my.
Touch of you? We put it on my keyboard. Do any of y'all need some scratch paper?
Oh, it takes.
Here you go. That's 2. We give 1 delay.
On this day, Mr. Winner?
Okay, good. Just on my keyboard, it's fine. Don't need any paper over here? You're welcome. Scratch paper over here? Okay, we're gonna give it a shot, at least 4 questions.
You got it there right now.
40 minutes, you could probably do even more than that.
That would be a good disguise though.
Wait. On the back.
Yeah, I don't be on the front.
But then you're so stupid. Did you try the medicine?
Medicine? Mr. Warner.
Yeah.
I looked at my grade book and I was like, oh my gosh, I have a 50. And I was like, oh, this is 30.
For the test review? Oh, but you just turned it in, so you're good now.
Brother, mom didn't text me yet. She's out for a game.
She's where?
She's out for a game.
Yeah. She hasn't checked you in a while, your grade. How often does she check them?
Well, she usually gets like a text from the test. And catch it correctly.